On another fun Tuesday, let's talk about a database called Elasticsearch. Has anyone heard of Elasticsearch? Okay, I'm going to have to turn my camera so I can talk that way. I mentioned it the other day that we said, yeah. So tonight, let's look at that a little bit. So here's the Elasticsearch website, elastic.co. From their site, Elastic is a distributed, open source search and analytics engine for all types of data, including text, numerical, geospatial, structured, and unstructured. Elasticsearch is built on Apache Lucene. It is known for its simple REST APIs, distributed nature, speed, scalability, and it is the central component for the Elastic Stack, a set of open source tools for data ingestion, enrichment, storage, analysis, and visualization, commonly referred to as the ELK stack or the Elastic Stack. I actually did a video series on Elastic 2 years ago. It's available on O'Reilly and Pack Publishing and a bunch of places, but there's a lot of cool stuff that Elasticsearch can do. So when do you use it? Elasticsearch has a lot of use cases, and it was originally built as a application searching tool. So a search engine to power a website or an application, something like that. So you could have like all the data, all the web pages from your Mike's Bikes or your blog or whatever stored in Elasticsearch, so you can search and find articles on a certain subject or publish in a certain date range, that kind of stuff. Since then, it has been used a lot with time-based data for logs, metrics. There's been a lot of cybersecurity use cases, application performance monitoring. Anybody use Datadog or heard of Datadog for application performance monitoring? It's a very popular platform that people can plug their applications into. It's all built on Elasticsearch, which is kind of cool. So how does it work? So we have in our relational database, we have a database engine that we insert data into that we can then query with SQL and all that good stuff. Last week we talked about Redis, and Redis doesn't have that kind of SQL language, but it has its own command structures. Elasticsearch is more like Redis in that regard, although the data structures and data types are vastly different. Raw data, whether it's from an application log file or a system log file or data from your website or from some application you're inserting, this raw data comes into the Elastic ecosystem. It gets transformed to kind of a standard format if you wanted a standard format of data, ingested into the database search engine itself. It gets mapped to a data type. It gets stored in Elasticsearch. It gets organized into indexes, and then it is made redundant for safety and scaling. If you think about a distributed system, the Postgres engines we've used have been like one engine on our local system. You can have an environment where you distribute across multiple servers your Postgres nodes or cluster. Elasticsearch is the same. It is built from the ground up to be this distributed system to store the data across multiple servers. One of the reasons it does that is for safety. So imagine you have 3, 4, 5, 12 nodes in your Elasticsearch cluster, and one of them gets exploded or unplugged or whatever. The data is redundant in the cluster, so you won't lose any data. Elasticsearch is super smart when it comes to how does it store this data across the cluster. And then scaling as well. So when you have parts of the data spread across multiple nodes, then inserting the data can then be distributed. The load to insert the data, the load to query the data can then be distributed across your cluster, therefore increasing its overall speed and capacity. So everything in Elasticsearch is stored in an index. So the index you can think of, they used to say you could think of it like a database table, but they've kind of changed their analogy. But we'll use that for today. So an index can be thought of as a table of a whole bunch of documents. So in that table, you can have all of yesterday's log files from your application, or you can have a index of your one website and another index for your internal company website. It's a way of kind of organizing data for later querying and management of the data. So if you think about collecting historical data from metrics from a bunch of servers or something like that, if you store them by day and you don't want to store anything over 2 months old, it makes it really easy to delete data that's 2 months old if all of your index names are timestamp based. The name itself has a timestamp in it. So just like if you had a SQL database and the table was time based was defined by a time, then if you just wanted to get rid of a whole day's worth of data, you could just delete the index with that timestamp in it. The inverted index is, since this is a full text search engine primarily, you use it to search for words in a recipe or words on a blog or something like that. The data can be indexed, lowercase indexed, unlike the capital index to talk about the collection. It's indexed so you can search it very quickly. The data structure it uses is called an inverted index. It's very much functionally like an index we would put on a table in Postgres, where the structure of the index is representative of the data that you're storing, basically with pointers back to where you can find that data in your overall database. Elasticsearch is exactly the same. So if you had a structure with city information in it, or some city state description, that kind of information, the index on your city fields would be the list of, or could be a list of the cities. And those cities would then link back into the overall database. Where are those records that correspond to this word or this city name? So that's they call it an inverted index for every unique word. And then for another overview, Kibana is a user interface that Elastic provides that you can use to discover or find or query and dashboard and graph all the data in your database. And so we'll show you what I was going to do was go into an Elasticsearch engine, or that's running in the cloud, just to kind of show you what's in there and how we can use the data. Last note though, before we do that, any programming language, for the most part, has bindings to Elasticsearch. It's third-party libraries you can install in your application that allows you to do insertion of data, querying of data, getting the status of your cluster, that kind of stuff. But all of that actually happens over a RESTful API or an HTTP-based API. So any language or program that can interact with HTTP or over HTTP can be integrated with Elasticsearch as a consumer or producer of data. So it's a really powerful engine that is used in a lot of places. All right, so let's go through some stuff. So any questions so far? I know that was kind of a super quick overview of concepts you don't know of yet. And so I want to go through, so I'll basically go through all of that again while showing you what it looks like in Elasticsearch. But any questions so far?
So you're saying I'm sorry, Ismail, I have a good question.
Yeah.
So the Kibana that you just said, is it just a programming language, or what is it?
Kibana's it's a web application.
Web application?
Yep, it's a web application that the company Elastic has created that we can use to play with our data or to interact with our Elasticsearch cluster.
So next to Kibana, does Elastic use any other web application as well, or only Kibana? Is that something that you can add on, or something that you can choose, or if you do your database with Elastic, you have to do with Kibana, but not other programming language?
Nope. Yeah, so Kibana is just a web application. The Kibana source code uses Elasticsearch libraries to interact with the Elasticsearch cluster. Nothing stops you from making your own application that interacts with Elasticsearch. Elasticsearch is like the database engine itself. There's a whole lot of other applications in the ecosystem, like applications to put data into Elasticsearch, applications to monitor your system and store data in Elasticsearch. But Elasticsearch itself is the core database engine. And so we call it a document store database or a full text search engine database, as opposed to Postgres, which is a relational database.
Yeah, I think I just misunderstood the different notions, but I think I'm got it. Thank you.
Yep. All right, so this is Kibana, one of the many views within Kibana that you can have. What I did, I went to the Elasticsearch website, and you can have a demo cloud-based Elasticsearch infrastructure run for free for a couple of weeks. So I set that up this morning or this afternoon, and they have example data sets if you want to do like what I want to do and just kind of explore what's going on. So in this interface, we have a whole bunch of different things. So at the top, we have a time-based histogram of data. What this is showing us, based on our query, which right now it's an empty query of show me everything, it's showing from 10:21 midnight to now the trends of when data gets inserted into the database. More accurately, based on the timestamp of the records in the database. So the data that is, whenever the data is put into the database, the data itself has a timestamp or field on the data for a timestamp. Just like you can do a last modified date or an insertion date or something like that in a Postgres database. So what this is showing is, if you've used Splunk or anything like this, you'll see this kind of histogram showing this is kind of the trends of my data. It's up and down throughout the day. That's helpful if you're looking for things like trends, because the human brain can find trends in graphs like that really, really quickly. So if we look at the actual data, so if we let's go to one of these peaks. If we hover over that, we can see in this time range, which seems to be a 3-hour time range, there are 68 documents. You can see it says count 68. There are 68 documents. In this time range, 64, 17, and then 6. Below is a list of the raw documents. So I can expand it with this little arrow thing, and I can see what that data looks like. So relating this to a relational database table, each of these attributes could be a field on our table or a column in our table, which means if they're all of the same data type, document type, all of these documents will have a bytes attribute, an agent attribute, a client IP attribute, what else? A host attribute, where's URL? And that's what I'm expecting, URL attribute. So, and a whole bunch of other things, refers, request information. There should be a method somewhere in here. Maybe not method. What am I looking for? Oh, it's not there where I expected it. So, can anyone guess what type of data or where this data came from? Just by looking at the data itself.
JSON.
That was the database. That was how the data was transferred. JSON. Yep. But what application do you think was the source of this data? Close. Firefox was close. These are web server logs. So this would be my google.com web server or my chrissblog.com web server. So my web server itself, the things that is serving my HTTP documents, is going to log every request that it gets. And so if we think about it from that way, I am logging an elastic.co/download/elasticsearch URL. So someone went to this URL. They came to it, the referrer, from Twitter. They are using Firefox 6 Alpha 1 as their web browser version. The client IP address where the client is 78.27.215.203. The IP address of the web server is 78.27.215.203. The client is running on OS X with 20 gigs of RAM. So this is the kind of data you can get from a log file, or from a web server log file. So over time, you get lots and lots of records, especially if you're on a popular website. But this is the format most likely that may have come out of the web server as a JSON document. But before this document got to Elasticsearch, it was most likely in a JSON format, or one way or the other. But what it's showing you is all those data attributes in a JSON format. So why is that exciting? I think that's super exciting, because now I can see using this, I can see the traffic on my website throughout the day. So now imagine I were building something to monitor my website for security purposes. I could start looking for known bad IP addresses or known bad request URLs for someone trying to exploit a vulnerability in my web server or something like that. So I would use this for lots and lots of reasons. All right, so that's kind of like that's the documents in Elasticsearch and how I can see it in Kibana. As I said at the beginning, this is a full text search engine. The entire reason this type of database exists is to be able to do text-based searching. Yes, I can do numeric searching. Yes, I can do geo routing based searching with my boundaries and all that stuff like I can in Postgres. But it's the text that matters. And so if we think about this website now, or this view, almost like a shopping website, like if I were at Lowe's.com, on my left, or I would see these things that are called facets or something like that. And so like if I were looking for tools, I would find the category and find the value tools. Well, here I can look for my referrer and say, okay, well, let's see what my popular referrers are. And I can see this Twitter URL, these two Twitter URLs are pretty popular. Most of the traffic's coming from the Elasticsearch website itself. So I can click on this plus sign and it updates my query to say, only show me things where the referrer value or referrer field has the value of this. This must be a blog post by Ravish Malhotra. And again, my histogram gets updated so I can see that there are 3 events that match that criteria in the past 7 days. So that's kind of cool. What else can we do in Kibana? That's my demo. So this now is another view, which is not Kibana, but this view is what you could build if you were building your own website, your own application on top of the data. It's a very basic example, but this is following more of that website search pattern. So this would be one of the pieces of data in my database with a description field, a title field, and all this other data. And on the left here is where I can start building my own capability by exposing the facets of data. So I can expose the state field and show that 9 of the records in my search results have a state value of California. So I could click on the California and now my search gets filtered. So now I'm building this filtered search capability, whether it's a web application like Lowe's.com, Amazon.com, or an application in your student information system where you're trying to find information about students. So imagine I had a field for grades or current grade. I could click on and find all the students that were currently failing their classes. And that could start giving me a report so I can start calling my students or something like that. So this is pretty interesting. I'm curious why one has California and Nevada. Let's see. So this has
Yosemite is not in California, right?
well, I'm going to look at the data and see if it looks like these are national parks. And so I'm curious now if one of these national parks is in California and Nevada. But it doesn't look like it. So that's odd. Interesting. Bug, maybe? Who knows? But anyway, so you can add multiple filters when you do this kind of stuff to find specific data points. So apparently Yosemite was founded in 1890. October 1st, 1890. All right, so that's an example web application that you could build. You could make a web application that natively natively made API calls to Elasticsearch. So kind of a single page application that used Ajax to make HTTP calls to Elasticsearch. That way you wouldn't need a backend web server or application server. I want to show the dashboarding capabilities because dashboards are super fun. I haven't used this version yet, so I'm kind of curious where it is. Oh, here. Nope, not what I wanted. There we go. All right, more Kibana stuff. So I can build dashboards. It's all based on data. So I've been using the word facet for things like categorizing things, like the state, the type of tool, whatever. When you run the queries against Elasticsearch itself, it uses their aggregation framework. And so the aggregation framework is essentially the same as us doing group by statements in our relational database. But the cool thing here is that the aggregation statements are only querying the indexes, the lowercase I indexes, those reverse, whatever they called it, reverse tree indexes or something. What was the word? Now I lost it. Inverted index, the inverted index. And so they're super, super fast. But here I can start doing visualizations of my data. So this is where you can start building a heads-up dashboard for the state of your applications. Like if you're running a web application at whatever company you're working for, you could build a dashboard here that allowed you to see, green, red, yellow status of my my application. You could view average response times. You could view error messages in aggregate, that kind of stuff. So here as an example, I'm using the aggregation to figure out my number of visitors by operating system. So group by statements. And here I can see I have 302 iOS users. So iOS users. Windows XP, OS X, Windows 7, Windows 8. So just kind of top N in a chart. I've had 814 unique visitors. Response codes over time and annotations. Those are kind of neat. So this is saying at this point in time there was an error, but here's my average, the trends of the response code for my application. So 200 is a good response code. 404 is a file not found response code. 503 is an error response code. So I can just kind of see at this point in time biggest trend. So look for this one. 16.7% of the requests ended in a HTTP 404 response or a 503 response. Usually you want to see here where 100% are 200. Scatter plots. I love heat maps. Heat maps are my absolute favorite data visualization. So I can look at this and I can say heat map, is this country? China, India, US, ID. What would ID be for a country? Indonesia? Maybe. NG. I got nothing. But whatever it is, you can see during this time of the day, the majority of my traffic is coming from China, India, and the US in this heat map, but with more in China. There's a name for this visualization. It's a tensor map, something like that. I forget what it's called, but showing source and destination. They call it a sand key chart. Cool. So the source of the request and the destination of the request. So this is a global infrastructure. So we can see that traffic from India gets primarily routed to India, the US, and China. Traffic from the US gets routed primarily to China, India, and the US. China, India, US. But the traffic gets distributed across the globe on my response, which is kind of cool. Total requests and bytes, another geo map view of this data. So these are the kind of different visualizations that you can build into Kibana. Unique users and average bytes. All right, what else do I have here? Maps, graph, visualize. Oh, well, let's see. Do they have stack management? Here we go. Ingest nodes pipeline. So this is how the data is getting into my Elasticsearch cluster. So I'm using XPack, which is another add-on package in the Elastic ecosystem. But XPack is the data coming in. There's no logstash pipelines. Beats central. Okay, they're not using beats. There we go. Indexes. So I have one index. Kibana sample data logs. Click on that index. There's one primary shard and one replica shard. This is that resiliency. So replica is that backup of the data. So here's settings information about the shard. This is all like that management kind of stuff where if you were building your own Elasticsearch cluster, it would be important to learn what a lot of these data fields mean. Show me statistics. I want to see statistics. Snapshots, index life cycle. But I want to show it to me in visuals. Templates. No reports. Security, Kibana, stack, upgrade. They have built-in backup capabilities and all that kind of stuff. Security. Oh, stack monitoring. That's what I was looking for. Turn on monitoring. So basically now, for monitoring, Elasticsearch will use itself to store monitoring data about itself. It's kind of cool. Whenever this happens. There we go. So I can see I have 3 nodes in my Elasticsearch cluster. They are all green. Node 0 and 1 have shards data stored in them. Looks like node 3 does not store data, but it's used, they labeled it tiebreaker. So a way to make sure that the other 2 nodes are working together, although it's not storing data. Oh yeah, it's a much smaller node, only 2 gigs of data memory versus 32 gigs on the other servers. And then I can see the health of my indices, my indexes. I only have 1, but it has 14,000 documents in it. So, back to this. Let's go for the last 7 days. So that's a super, super quick overview of Elasticsearch. I think the 2 takeaways I want you to have are the 2 primary use cases of Elasticsearch. One is to build an application search. So as this example, where'd it go? This example is is a National Parks demo reference UI, as if I built this myself. This is a kind of thing you would build to search your internal company documents, your products on a website, that kind of stuff. If I were doing this, Postgres would most likely be my primary store of products. As a relational database with all of its ACID compliance, that would be the primary store for all of my products, all of my customers, company information, staff information, all that kind of stuff. Then I would have some process, and Elastic has tools to do this, some process that would regularly take that data from my Postgres database and put it into Elasticsearch as a reference, as a copy of the data. Terms you'd use are the system of record for the data would be my Postgres database. That's the official record of the data. If I have any customer management tools or employee management tools like Workday or whatever other application I'm using to manage my pay raises and stuff, that tool would use my Postgres system of record. That would use my system of record, official, authoritative Postgres database. If I wanted to build applications like this for searching, or to give a unauthenticated view to some data, or read-only view of some of this data, and I wanted it to be in this full-text search engine concept, I would have a process to load it into my system of reference versus system of record, the system of reference to be able to reference that data without having access to that real data source. You can almost think of it like a database view, right? In that model. And so that's typically how you would build this kind of search, is application search. But if I were logging records from events, sensors or servers or security system, who logged in, who logged out, all that kind of stuff, I would stream that data into Elasticsearch, but more on that time-based concept, where I could get a view like this time-based view to be able to do research and discover data that I may not have written an application to do, but I could use out-of-the-box Elastic tools like Kibana to do that. Yeah.
Does Kibana allow you to edit any of the data, or is it mostly, or is it all just query and search?
It's all query. I do not believe there's any capabilities to edit the data, as far as I know.
Does it have capability to transform or manipulate data except query? Not
once it's stored. Yeah, I mean, they have APIs that you can modify data. Once it's stored, you can change. If I wanted to change the geo.source field, I could change it to whatever I wanted it to. Kibana doesn't let you do that. But that processing you typically do on ingest of that data. Let me see if they have a picture of how it all works together. Search. Maybe logstash will show me a picture. Man, this might be a decent view. What this is showing is that I can have different sources of data on the bottom. And logs, I think this in the middle is supposed to represent logstash, but logstash is one of the tools in the ecosystem that can process that data before it gets stored into Kibana. Before it gets stored into Elasticsearch. So web servers typically don't output things like geolocation of the request. They output the IP address. And so you'd use a tool like a logstash to take that IP address, and before it gets stored, look up what the where that IP address maps to in the global geography, update the original document before it goes into Elasticsearch. So that's a logstash would be. Let's see, they need a good picture. One of my good friends is a Elasticsearch solutions architect, and I really wish I'd thought to get some material from him before tonight, because I could have had like professional demos of stuff. But I think this got the message across. So if you thought about your application that you're designing for the semester, could you envision building a user interface on top of it like this to search it?
That'd be awesome. But I'm not sure it'd be possible in a semester. So.
Oh no. I mean, depending on how much time you wanted to invest in learning how to make it all work together. But like logstash it's a command line tool. It's a configuration driven thing. One of it's centered around inputs, input, modification, and then output. So one of the inputs they have just out of the box is a JDBC driver, so a Java database driver. So you could plug it into your Postgres database, and it's smart enough to know how to query your data and bring it right into Elasticsearch. So I think that's kind of cool. That could be a fun experiment if you had the time. And then you could start building dashboards like this. I love data visualization. It makes me happy. Especially when it's all just configuration driven. Like I don't have to do anything besides customize time range. No, there's no cancel. There's maybe I can't edit this. Can I? I can refresh it. Filters. Oh, edit. There we go. Oh, this is the dashboard itself. So if I went to the dashboard, I want to go to visualizations. So the visualizations are what go into the dashboard. So here I could do the source and destination sand key chart. So it shows me what it looks like. But on the right here, this is how it's configured. Now, this is a lot of configuration. It's not as simple as it could be. But you can control what the hovering looks like. You can control what the data field names are, that kind of stuff. So there's all kinds of cool stuff you can do. What's a simple one? Heat map. Here we go. So yeah, the heat map is a really super easy one. You say I want a unique count of client IPs bucketed, meaning grouped by geo.source and hour of day. So my y-axis is the geo source, and my x-axis is time of day. Hour of day. So it's a very simple configuration to build the heat map. And I think I have the options to change colors and all that kind of stuff, but basic configuration is really straightforward. So let's see. Logstash JDBC post source. Here you go. Insert into Logstash, select data from the database. So there's a Logstash plugin, JDBC. Example database. And here's how I configure it in Logstash. I have an input of type JDBC, connection string to my database, user, where my jar file is, just like we did in SQL Developer, where the Postgres jar file is, what the driver class is, and what my statement is. And in this case, the output, they're just printing it out to the screen, but one of the outputs could be Elasticsearch. There you go, synchronizing data into your table. So update, insert, update. That's where my query go. I'm trying to see if there's a way to do a query or time-based query. But here's a big query I can load to put all the data in there. I can store my SQL in a file. And here we go. Output is Elasticsearch. In this example, that's how they put the data in. sample visualization. So their documentation is really, really good too. This is a couple years old, so I'd make sure to find the updated versions of this, but it should be that simple. This is one of the reasons I have built multiple commercial products around Elasticsearch, and I use it all the time. I actually, my friend from Elastic and I run the Richmond Elasticsearch users group. That's been a lot of fun, although we can't meet this year, obviously. But it's something that I think is pretty awesome when it comes to technology.
Hey, Chris.
Yeah.
Hey, quick question. You know, you're saying Elasticsearch is more like a data of reference, and it's like a table view. Then we can do the same thing with accomplish the same thing with building all the views with all screens, and then search engine and in SQL database. And then why do we need to transfer this data into Elasticsearch and then do everything there? It's just the extra step. Yeah.
So I think you actually asked something very similar last week about Redis. There are many reasons you would do this. So Postgres itself has a full text search engine capability. But if you were putting your website, as an example, a public-facing website, Mike's Bikes, right? Mike'sBikes.com, accessing the same database that your your point of sale system was using, you run the risk of having overload issues when you're trying to make a sale. So what you do is you would take the data from the system of record and offload it to a database engine that was purpose built for things like a website use. And sure, you could do it in Postgres as well. You could have a offloaded Postgres. But the accessibility, the ease of data access within Elastic, and all that aggregation tooling that's built in and is much easier to do than a whole lot of group by statements. It's another tool in the tool belt to use.
Okay. So is it fair to say that the reason why Elasticsearch is getting popular is because of Kibana, because they already have a very intuitive platform for you to do data displays and
It's absolutely one of the reasons it's popular. Primarily, though, I'd say it is popular because it is free and it is extremely scalable and reliable. It does, like I said, I've run multiple production applications with Elasticsearch, and unless I did something stupid, Elasticsearch never had a problem. So it's extremely reliable, and you can put in a whole ton of data. And if you start to overload, like your CPU or your memory usage across your cluster, you just add another node, and it linearly scales.
Okay, thanks.
Yep. Great questions. Anything else? If not, have a fantastic evening.
Thank you.
Thank you.
Thank you.
Thank you, Professor.